Now to circumvent this pitfall, we have a solution, and that solution is known as partial pivoting. So what is partial pivoting? I'll explain it to you with an example. Okay, so basically what happens, or let me explain it to you here. So let us say we have a problem of, let us say, this is the problem. Now, according to partial pivoting, what you're going to do is you're going to consider the first column, okay, and you're going to find out which is the highest value of an element, highest absolute element, value of an element. So in this situation, if you see it's 9, okay, that you are going to bring it at top. That means you are going to replace it by 5. So partial pivoting says that when in a column you'll find out the elements, and whichever element is higher, you're going to take it on the top. So after partial pivoting, what is going to happen? This row becomes 913, this becomes 523. Similarly, the changes that you are going to make here, you have to make it here. So this becomes 8. So this is known as partial pivoting. So before starting any row transformation, what you're going to do is, whichever element, you will consider a column first, whichever element is highest, you are going to bring it at the top. Now in the next step, what you're going to do is you're going to make this element 0 and you're going to make this element 0. Okay, so let us say you have already made this element 0, and let us say you got a value of 14, and let us say you got a value of 0.33, and let us say you got a value of 0.72. okay, and here you got a value of 10 by 11. I'm just taking an example, 14 by 8. So now what you, according to Gauss elimination, what you have to do, you have to make this element 0. But what we have to do here, we have to perform partial pivoting. So according to partial pivoting, what you're going to do is, the element which is highest, you are going to bring it at top. Okay, now if you see here, I mean, you are going to place everything in an ascending order, highest, then next, and then the lowest. So here you'll have to perform partial pivoting. So if you see here, this the value of this element is 0.72 or 0.33. So what you're going to do is you're going to replace it by this. You're going to bring it here, and then you're going to bring this here. So once you do that, what is going to happen? This is going to be 913. This is going to be 0.72. This is going to be 14 by 8. This is going to be 0.33. This is going to be 10 divided by 11. This is going to be x1, x2, x3, and this is going to be again . So this is just an example. Okay, I just wanted to show you what happens in partial pivoting, but now what you are going to do is we are going to solve an example. Okay, so let us take a real example now. So let us say we have a system of equation that I am writing it down in matrix form. That equation is 8, 2, minus 2, 10, 2, 4, 12, 2, 2, 3, minus 2, 4, 6. So let us say you have to solve this problem by Gauss elimination. Using partial pivoting. So here in the problem itself they have said that you have to solve it using partial pivoting. So according to Gauss elimination, what you have to do, the first thing you are going to do is you are going to make this element 0 and then you are going to make this element 0. Okay, but since this is Gauss elimination with partial pivoting, so what you are going to do is you are going to consider this column, okay, and whichever element is the largest you are going to bring it at the top, then second largest, and then the lowest. So this is pivoting. This is going to be 12 2 2 10 2 4 8 2 minus 2. This is going to be x1 x2 x3. Since you have shuffled the row in here, you have to also shuffle it here as well. So then this becomes 6 4 minus 2. So this is your first partial pivoting. Now what you have to do is you want to make this element 0. So if you want to make this element 0, what you are going to do is first you are going to make this element 1 and then you are going to multiply by it and then you are going to subtract it to this element. That means what you are going to do is you are going to write down what? R1 R3, you have to subtract R1 and R3, and what should be the multiplier? You have to make this 1 and then you are going to multiply by 8. You are getting it? So if you do that, what you are going to get is, and that you have to, whatever result that you are going to get here, you have to put it in R3. Okay, so then what is going to happen here? Again, R1 and R2 remains the same. What is going to happen is only R3 is going to change. Okay, so this becomes 0. If you solve this, this becomes 2 by 3. If you solve this, this becomes 10 divided by 3. This is going to be x1 x2 x3. This is going to be 6 4 minus 6. Okay. Now the next thing what you are going to do is you are going to make this element 0. Okay. Now to make that element 0, what you are going to do is you are going to use this row. So you are going to divide it by 12 and then you are going to multiply it by 10. So you are going to write down R1 into, first you are going to make this 1, so it is going to be divided by 12 and then whatever the multiplier is 10, and then you are going to subtract it from R2 and the whole thing goes into R2. So 10 minus of 1 divided by 12 into 10. So if you do that, this is 12 2 2, this becomes 0 1 by 3, 7 divided by 3, so 0. This remains the same, nothing is going to change in this row. Okay, nothing is going to change in this and this. The only change is going to be here, that is minus 1. Okay. Now once we have done this, okay, or let me try something new. Let me write down this in decimals. So if you write it down in decimals, comes out to be, just a second, or I'll write down this because I want to show you, I want to demonstrate you about the decimals. So let's write down this in decimals. So this becomes 0.66667. Okay, so we are taking 6 significant digits. 1, 2, 3, 4, 5, 6. 6 significant digits. This is going to be, oh no, so this was 0.3, sorry. 0.3333 66667, and again this was this was 10 divided by 18. So this was 2.33333. So I have taken 6 significant digits. Okay. So I think the first stage is done. You have already made this element 0 and you have already made this element 0. Now we'll focus our attention on this column. Okay. Now what we want is we want to make this element as 0. But before that, if you see, this is a problem where you have to perform partial pivoting. So if you are going to perform partial pivoting here, what you are going to do is you are going to bring the highest value on the top, okay, or you are going to arrange it like highest, lowest, 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 highest, second, third highest, and then lowest, like this. So in this situation, if you see, what you are going to do is you are going to interchange this. You're going to bring it here and then you're going to bring it here. So if you do that, this becomes 66667 minus 3.33333. Okay, and this is going to be, this row will come down 33333 16. Okay, x1, x2, x3, and this becomes 6 minus 6 minus 1. So once you have performed pivoting, now what you have to do is you have to make this element as 0. Now to make this element 0, what we are going to do is we are going to make use of this row, that is your second row. So what you are going to do is you are going to first make this element 1, that is you are going to divide it by 0.666 I just have to be careful here, 67 into multiply with this value, that is 0.33333. Okay, and then we are going to subtract it from R3 and we will replace whole R3 by this value. So once you do that, you will find out the value that you are getting is, this row is going to be the same. So let us first write down this row. Again, nothing is going to change in this row. So keep it as it is. Everything that is going to change in this row. So this was already 0, but now using this operation, this also becomes 0. And if you do, you'll realize that this becomes 4. And if you solve this, you'll realize that this becomes 2. So once you have made this 0, and this 0, let's use back substitution. Okay, so you are going to multiply this with this. So that comes out to be, I'm doing it here. So 4 times of x3 is equal to 2. So x3 comes out to be 0.5. And if you similarly do this, you'll find out the value of x2 that you're getting is minus 6.5. and the value of x1 that you're getting is 1.5. So this is known as your partial pivoting. So as we discussed, there are two pitfalls. First is division by 0 and second is by round of error. Okay, division by 0 and then round of error. So the remedy for those pitfall is, both this pitfall is, yes, partial pivoting. And also, whenever you're dealing with decimals, make sure that you use 6 significant digits. Now, if you see in real life, this Gauss elimination, you're going to perform it on PC. Okay, you're going to perform it on the software. Okay, maybe I'll discuss it in the next segment. Okay, this is where I'll end.